All right, let's do this. We're going deep on quantum computing today.
Buckle up.
Yeah, seriously. The stuff you sent over, honestly, my mind is kind of blown.
It's a trip, that's for sure.
No kidding. You're talking potentially changing, like, everything.
Oh, yeah. Medicine, materials, things we haven't even thought of yet.
Right. But the source jumps right into quantum superposition and entanglement. Whoa, hold on.
Big words, I know.
Uh-huh, a little bit. Can we, back up? What is quantum mechanics in simple terms?
So think of it like this. It's the rule book for the tiny stuff. Atoms, particles, their world's totally different.
Okay, so different rules down there.
Totally. Like, down there, things can be in multiple states at once. That's superposition.
Wait, what? Multiple states at the same time?
Yep. It's wild, right? Imagine a coin spinning in the air.
Got it. Heads or tails, but not both. Yeah.
Exactly. Until it lands, it's both. Particles are like that. Until we look, they're blurry possibilities.
Okay, so that's superposition. But how does that make a quantum computer powerful?
Here's where qubits come in. They're like the bits in our computers, BUT. A qubit can be 0, A, and D, 1 at the same time.
Whoa. Ours are either, right? 0 or 1.
Yep, that's the limit. But qubits, they do both, thanks to superposition. So a quantum computer can explore tons of possibilities at once.
So it's like parallel processing on a whole other level.
Exactly, and that's just the beginning.
Okay, on to the really weird stuff. Entanglement.
Yeah!
Even Einstein called it spooky action at a distance, right?
He wasn't kidding. It's like two particles, no matter how far apart, are linked. You mess with one, the other reacts instantly.
Faster than light. That's breaking the rules.
Well, we don't fully get how it works, but it does. And the source mentions some wild applications, right?
Yeah, like unhackable communication. That's got to be entanglement at work, right?
For sure, if you try to eavesdrop on an entangled message, you mess up the entanglement. Instant detection.
That's insane. But still early days, I guess.
Definitely. Quantum cryptography is promising, but like early research stuff.
Makes sense. So the source also talked about quantum algorithms. What are those exactly?
Think of them as like instructions, but tailored to use the weirdness of quantum stuff.
Okay, so they're not like the algorithms we use now.
Nope. They exploit superposition and entanglement to do things regular computers just can't.
Like what? The source mentions Shor's algorithm. What does that do?
Well, Shor's algorithm can factor really big numbers. Sounds boring, but it's what our encryption relies on.
Oh, so a powerful enough quantum computer running that algorithm.
Could crack most of our online security. It's a big deal.
Yikes. So it's not just speed, it's like a whole different way of computing. And that leads us to quantum supremacy, right?
Right. That's the point where a quantum computer does something a classical computer basically can't, no matter how long it runs.
Like a knockout punch. Game over for regular computers.
Kinda. It's proof that quantum computers aren't just faster. They can solve problems we can't even touch right now.
And we're already there on some things, right?
We are. There are specific tasks where quantum computers are already superior. Pretty exciting times.
That's wild. So, one last thing from the source. Quantum cryptography. Sounds like sci-fi stuff.
It kinda is. The idea is to use quantum mechanics to make unbreakable codes.
I'm listening. The source mentions something called quantum key distribution.
Yeah, QKD. Basically, it uses photons' light particles to make sure any eavesdropping is impossible. Mess with the photons, you mess up the key.
Whoa. So like spy-proof communication.
In theory, yeah. Early days, but huge potential.
So we've covered a lot. Superposition, entanglement, quantum algorithms. My head is officially spinning, but in a good way.
It's a lot to take in, that's for sure.
It is, but it's also incredibly exciting. It feels like we're on the verge of something truly revolutionary.
Absolutely. We're just scratching the surface of what quantum computing can do, and it's moving fast. Who knows what the future holds?
Yeah. And that brings up a big question. This tech is based on totally different ideas than our computers. If it takes over, will it change how we see the universe, not just technology?
Deep stuff, right?
Definitely something to think about. Thanks for taking this deep dive with us, everyone. Until next time.
Stay curious.